Hello, this is a note about great circle sailing. We have actually another article about that. I'll just put that in the link. I just thought of it. We have several articles on great circle sailing, but one of the beauties of being a school is we get good questions come up, and we had a question come up today about solving various types of great circle navigation problems. And one of the things that occurred to me is that one very good way that is free and very powerful is all the great circle problems can be solved with qtVlm. And so what I want to do is illustrate a few examples of that. And but just let me remind those that are registered for any of our courses, or if you have a web card. You don't have to be in a course. You can just have one of these web cards and get access to all our resources. But where you would get practice with the Coast Guard exam questions is you'd go to resources here, click the resources, then under here click practice problems, and then down here random generator. Then you would go here probably navigation problems, and then great circle, and let's say, I don't know, let's look at 50 in a row, say, and then you create that, and then you have this exam, which is all the types of great circle problems the Coast Guard's ever asked, and you can work with those. And then you turn in these quiz, you make them 10 questions, 5, whatever you want, or whatever types of questions you want, and then you practice. But I'm going to show now that one way to solve that is with the qtVlm. So I think I'm done with that. There's the qtVlm. Here are some samples that we'll do that I just pulled out of there. By the way, I did discover that at least one problem, one of these great circle problems that's in that data set, is just got bogus data in it. It's not right. And also this number, one of the questions, let me just say this, one of the questions also had a wrong answer. The answer was there, but it was not listed as the right answer. Anyway, so let's get to it. So this is determine the great circle distance and initial course from this point to this point. That's like the most basic, and essentially all navigation calculators will do that. In our textbook, we show various ways to do it. Various ways. There's lots of different ways to solve that problem. By far, the best way is just calculate it, or use a calculator or a nav program, or now I'm showing that how easy this is with qtVlm. So I put in, this is 5464. That's right here. I just put in the first, see there's got a first position and a second position. I put in the first position as a waypoint, and then I put in, oh no, this is the first position way down here. Oh, that's kind of interesting. Now I'm going to not dwell on that, but you see a great circle route is a kind of an S-shape going from over this part of the ocean. So you're starting here and you're going there, and then the way you would draw this line, the simplest way, is after you've got the waypoints entered, you just right-click it, right-click the waypoint, and go, oh, you can't see that necessarily. It's out of the visible range here. Let me, I got to do it this way. Right-click that, go to, oh, come on. Let's see, how do I do that? Okay, right-click that, go to More Options, and then draw a line to another POI. And in this case, 564 End. That's where we would want to go. And then you can change the color of it. You can do great circle or run line or both. And then you say OK. And then that draws that line. For example, if I said both, draw a line to another POI. Let me just say both. Then what it would do is would put the run line and that. Then when you put your cursor over that, it gives you the answer. And so in this case, for the run line, it's telling us that the distance is 6. Well, let's look at their answers here while we're doing this. 6, 7, great circle, 6, 7 nautical miles, 6, 7. Now, they're not going to agree because the Coast Guard is still assuming a spherical Earth, a pure spherical Earth. And this program, like some others, takes into account the average radius of the Earth considering it more of a doorknob. So the polar radius and the equatorial radius are not exactly the same. So you're going to get slightly different answers. I'll put a link in the description that explains those differences. There's actually 3 different solutions you can get for a great circle distance. Anyway, that's in there. So that's all there is to it here. You put in the starting point, the final point, then you put the cursor on here, and then the initial heading is 304.48. 304.48. Well, that agrees exactly. And what that means, by the way, the heading on a great circle is changing all along here. But it means, like if I did right click ruler tool, it means this heading coming out of here, right? This heading coming out. Oh, I didn't do the ruler tool again. This heading, great circle, more options. Ruler tool coming out of here. It's this heading, your initial heading. There you see 304.9 on the great circle at the top of that. So that's what escape. That's what that means. So that's the first, and that's really the simplest kind of problem. And you'll get those come up. Every kind of navigation test probably has some question like that. And so here's one. This is one. What is this? The vertex. Now the vertex, that's the peak in the inflection point. Really the inflection point of the route. The great. So here's 471, 5-471. So that is that's this one right here. Let me actually. I could go in here, edit, more options, draw a line to this, and then I'm just going to shut them off. You see, that's the way you turn that function off, by the way. You just go and undo it. So now we're doing number 2, 471, great circle distance from A to B, and they tell us the distance. Now that's not, we're doing 471. What do we get? Oh, okay. With this, by the way, when you use this tool of drawing a line from A to B, the toolbar, the tool tip that reads the latitude and longitude only shows up on the first time you do it. After you move off and do other things, you don't. So if I want to get that tool tip again here, what I have to do is just redraw the line. It takes 2 seconds. But that's not what we have to do now. What we want to do, what's the question here? The vertex, by the way, is the peak. Like on this curve here, the vertex would be somewhere around here, right? The vertex on this one is right in this muddle right here because that's what they're asking us. Okay, so they want to know. They tell us this. They tell us the distance. Oh, they tell you the distance and the heading and so forth. That's because there could be mathematical formulas that calculate that vertex, but we're not doing that. We're doing a much quicker way. We literally enter this waypoint, and you enter a waypoint, right? New mark, and then you would come in here like this one, 44, and then click this one, 45, 0.6 or something like that, and so forth. And that's all you do, and it takes seconds, literally seconds, seconds to put in there. So which one are we doing? 471. And then they want to know the longitude of the vertex. They tell us the latitude of the vertex. They tell us the latitude of the vertex, and then they want to know the longitude. Now, you would think that we could maybe do something like take this tool and draw it and trying to look for that tangent point, but that's not going to help us here. We look at their answers because their answers all look like that. Whoop, I got to shut that off. Their answers are all that close, so we wouldn't be able to tell the best one that way. So you cannot just draw the curve and find the middle. You would have to, for these problems, you'd have to do a little bit more. So one way to do it is I just plotted the answers they give. They're right here, these answers they gave. And so let me just go here. This is the right answer right here. And the way I would do, in other words, I've got these all plotted exactly where they said they were. That's the That's the latitude, 38 degrees, 9.4, 28 degrees, 18.20. So I just plotted that. Now, what I need to do now is I can just right-click this and do a ruler tool and see how far this is from the line. I want the closest one, you see. And this is like 2.2. Well, we could zoom in here and get a better value. Okay, and then you do ruler tool, and then this is whatever that is. More like, I can't see it exactly. Ruler tool. I don't think I have to work. Let's see. Okay, what is that? That's something like 2.2, 2.3. And then escape. Then you would go over to the other one. This, you know, the others. Here's the other choice. And then do that. Edit, no, ruler tool. And see, this one is now 2.5. So that's bigger. These are really, I don't know that. Maybe they're thinking you're computing these things. Anyway, this was 2.2, that's 2.5. And then when you go over to this one, this is a little bit bigger, and they just get bigger. Ruler tool. That's that. That's 2.5 again, something like 2.7. All right, so the answer to that problem is this. Now, this is not that practical a problem. And we see what the issue is. This great circle that they've chosen happens to go right through the islands here without hitting anybody, but you would normally have to deal with that more specifically. Okay, let's go on. This is what's this kind of problem? Your vessel, you're leaving Yokohama Harbor, you're bound for Seattle, and it's a time. Oh, they want to know your ETA. Your ETA. Now, actually, this is a little bit tricky. Sometimes they throw in, you have bunkering. You spend 15 hours at some particular port. So that's just, you have to do that. But this question does not have that. It just has this. So what we do is we just plot, we plot the route, and we tell it the starting time. We tell it how fast we're going. Now, the trick is they want the answer in local zone time when they arrive. And that is, they're in Seattle, zone 8, and they're starting out at zone -9. So the way you solve these problems, no matter how you're doing it, you always convert everything to UTC and then convert back to the local time once you get there. So we start out here, and we have to start that. You see, this is 1330, and that's zone 9, so we have to subtract that. That's actually starting at 4:30, then UTC, 4:30 UTC on this date. So you would set up a route. Well, the way you do that here, where is that? Oh, no, that's probably over here. Oh, yeah, it's over here. Yeah, this is anyway. The main problem that this never works is this is usually going in the ice. In modern times, though, this ice has been up there pretty high. But anyway, that's not always a practical route. But so what you do is you just coordinate the route. Well, okay. So first of all, let's do this. You go in and make a route, create a route. And so what I did, oh, no, wait a minute. Let me edit a route because I got it already there. Route, edit a route, and I call it 516 route. So what you would do is it's from the first mark, not the boat, and then put in a fixed date. And now you put in the UTC of the starting, 723, and now they don't give the year, but 2024, and that's here. So that's going to be the route starting time. But this route, at this point, doesn't know A to B, doesn't know where we're going, right? So this is one way to do it. Okay. Then the other thing is you plot the lat lon, add these waypoints, and then what you do then is you go in, and when you edit the waypoint, you put in that this is part of a route. And what route is it? It's this one you just called that, and this is route number 1, point number 1. Okay, and then this guy over here, which is going right, it pretends it's going in a straight one if you can down here, but it's not. These are not, I mean, realistically, this should be calculations to out to here, and then you do regular navigation in the sound and down. But anyway, you do the same thing. You go over here, edit, say it's part of a route, it's this route, and say that's number 2. So you have that set up. Then we have to do maybe another trick here with qtVlm. I want this thing to be this is a program oriented towards sailors to a large part. So usually you have to load a wind and a polar diagram and all sorts of sailing conditions and things like that. But we're just going to fool it for the moment. We're going to go up to boat settings, and we're going to go to engine and tacks. And what we're going to do is we're going to say, if the sailboat can't go 80 miles an hour, then turn on the engine and go 13 knots. So now I know that with no matter what the wind is or anything, it's not going to go 80 knots. So it's going to crank on the engine and it's go 13 knots. Okay, so that's the trick. So then we're done. I mean, it lays out the route and it tells us when we arrive. We arrive on August the 5th, 12:45. UTC, and now we're at zone 8, so now we have to subtract 8 hours because Seattle time plus 8 hours equals GMT, so it's a minus here, so you got 12 minus 8 is 4:45, so we get 4:45 August 5th. And you see, you do this 2 or 3 times faster than I can describe it. This is the right. Well, they have 4:38. I don't quite know that, but again, I know. I do know that. We don't agree with them on how far this is. Simple as that. And the reason we don't agree with that is they're dealing with a sphere, and the qtVlm is dealing with the average radius of the the geoid, WSG 84, I guess. Yeah, so forth. Okay, so that all makes sense. Our answer is better, frankly. Okay, now what's left here? You estimate. Oh, we did that one. Okay, so now then the Coast Guard has a whole series of sort of very different problems with navigation and great circles that are in fact much, they're rather time consuming to solve, with the conventional tools you've got in the test room or even on your boat. But these can all be solved very easily in the qtVlm. So let's read this one example and then we're done. Your voyage starts at Cape May. You're going north up that. The sea ice is north of 45 and west of 45 west, and there's extensive naval exercises within 150 miles of this point. Which statement is true? So what we do is we just lay out all this information we have, and then we'll be able to read right off the map, right off the chart, what's going on. So here's the, what is this one called? 661. 661. So you're starting here. You're going up here and you're going over here, and I drew that in the same way. I just said right click, more options, draw a line to another POI, and I pick 564 end. If I want to, I can make this orange or something. Okay, so there's the one we're working on. And then that's the route. Now I got to do the ice. The ice is north and west of 45. And so I just make this corner here at, 45, like that. And now this is just a way to draw a box, just to draw a box. And you can do that with what they call the barrier tool. This is a tool used in qtVlm to block off routing. So you don't want to, like if I don't want to go a certain way, then I can put a barrier up here and then not go through it. I think it's what Expedition calls note tools. But anyway, I'm using it just to draw a picture, frankly. That's it. So that's that. Then the other thing is there's naval exercises, edit, at 50 and 35, and then 50 and 35, they tell us there's within 150 miles, 150, where was that? North of that, military exercise, 150 miles up radius of this. So then I just add one range ring, 150 miles, right? So, okay. So this whole situation is set up. So first of all, we see that Navy, one of the questions. Okay, they say, what can best be said? Okay, let's look at the answers. The latitude of the Great Circle vertex is above, wait a minute, got to be careful. Some days they ask what is true, what is not true. Here they want what is true. The latitude of the Great Circle vertex is above 50 north. Okay, here's the vertex. I'm reading the latitude down here, and you see the vertex is here at about 46. So that one's not true. It's not above 50, it's at about 46. You must plot a composite sailing to remain south of the ice. And that's obviously the right answer. In other words, if I follow this, I'm getting into the theoretical ice pack. So a composite means you take a great circle, then you go like a rhumb line, and then you take a great circle. So that's almost certainly the right answer. Let's just see if there's any contenders for a right answer. The naval exercise will interfere with the great circle. No, that's 150 miles. We're that far off. That's not the answer. What is the last one? The shifting shoals northwest of Sable Island will be a navigation hazard. Now, that's the tricky part. You got to look up or Google Sable Island. I think that's Sable Island right there. It's a little sliver of something. Yeah, that's Sable Island right there. But yeah, that's Sable Island. I'd have to change the layout here to get labels on things and so forth, or load a real chart. You know, I'm not using a chart. I'm just using the back. That's Sable Island, shoaling northwest of there. Northwest. Oh, that's even worse. Does it say northwest? Northwest. Oh yeah, nonsense. Here's northwest. There's nothing. We're going this way. All right, that's the answer. So you see, this tool, qtVlm, is a big gun. It's a big gun, and you can come out and solve all these rather complicated sometimes navigation problems from the Coast Guard and other places just very, very quickly and decisively. And that's where I want to end. Thanks. Bye.